Hello everyone, welcome to today's Olympiad math training. Today we're gonna solve two advanced age problems. Age is closely related to our life, so let's see how it works in math problems. First, question number 1. Allison is 30 years older than Bernard. Last year, Bernard was 20 years older than Caitlin. Next year, Caitlin will be 10 years older than Donut. If the sum of the ages of the four of them was 180 years old 5 years ago, how old is Allison now? Because there are too many keywords, so when you are circling or underlining the keywords, you had better label different conditions. And actually, this question is a bit confusing at the first sight because, as you can see, all the conditions are related to different years. Last year, this year, and the next year. So confusing. So before we're gonna solve it, we need to know the basic property of age. Let's see. How old are you this year in 2024? Oh, great. Most of the students are 11 years old. And the second, you can guess how old am I this year? Oh, great. So actually, I am 27 in 2024. So what is the difference between our ages? What is the difference between that? Great. 27 minus 11 equals 16. Let's see. How old will you be next year? You will grow 1 year older and become 12. What about me? I will also grow 1 year older and become 28. I really want to always stay 18, but it's impossible. So let's see. What's the difference between our ages next year? Good job. It's still 16. What about the year after next year? In 2026, how old will you be? You will become 1 year older, and that is 14. What about me? Added by another one, so I will become 29. If so, the difference is still 16. Have you noticed something? No matter how many years later, how many years pass by, will the age difference change? It's always the same, because when you are growing up, I will also grow up. So the biggest property of age is the age difference never changes. Based on this, we can solve this problem in an easier way. No matter which year it is a condition about the difference between two people's ages. So we don't need to see which year it is, and just draw the line segment to show the relationship between their ages. Because the longer the line, the bigger the amount. So I'm using a long line segment to represent Alice's age. For Bernard, his age should be a little bit shorter, and the difference is just 30 between Allison and Bernard. You can label 30 in the Allison's lines. Second, Bernard was 20 years older than Caitlin. So for Caitlin's line, we need to draw a shorter line. And also we had better label the difference in the picture. The difference is 20. Then Caitlin will be 10 years older than Donut next year. So the difference between these two is 10. Label the difference in the picture. As you can see, we have just used the diagram to show the difference between the four people. Second, if I want to know what is the difference between Allison and Donut's ages, can you tell me at once? In the picture, it's really clear. The same line, the same length means the same amount. So this is also 10, and this is also 20. In this way, we can see that the difference between A and these ages should be 10 plus 20 plus 30 equals 60. And let's see, we know another condition. The sum of the ages of the four people was 180 5 years ago. This picture can be applied to every single year. So 5 years ago, the difference between them is also like this. If so, we know the sum of them is 180. In this way, we can also find how old was everyone 5 years ago. But before we are gonna use the 180 divided by 4, can we just do the division? No. Because only when they represent the same amount, we can just use division. Divide total equally, use division. Here, first we need to take away the extra part in the diagram. Because for the first part, they represent the same amount, so I use the same shape to represent it. It's more clear. And before we are going to use the division, we need to take away the extra amount. For Alice's age, 10 plus 2, 20 plus 30 is extra, should be taken away. For Bernard, we need to take away 30. For Caitlin, we need to take away 10. For Donut, we don't need to take away anything. In this way, you can see 4 triangles represent 80 years old. If so, one part should be 80 divided by 4 equals 20 years old. But actually, the 20 years old represents one part, which is just the Donut's age. For this question, we want to know Addison's age. So add the difference to Donut's age, which is 60. In this way, we can find 5 years ago, Addison was 80. So how about now? This year, Addison is 85. That's how we solve the first one. It should be D. For the age problem, the line segments are really useful. Also, we can use it in the question number 2. It is really hard because it's almost the last question in the grade 5 sophomore competition. Let's see it. When Bernard was as old as Hector is now, Bernard's age was 4 times Hector's age then. When Hector will be as old as Bernard is now, the sum of their ages will be 51. How old will Bernard be when Hector turns 18 years old? No matter which year it is, we know 2 relationships. The first one is a multiple. The second one is the sum. As long as the question is related to the sum and the multiple, we can use line segments to represent their relationship. And also we had better start with the multiple relationship because it's even more clear. And because it's an age problem, so there's a pattern which can always work. Age difference never changes. If we're gonna use one line to represent the younger Hector's age, let me use a ruler. It's much better. Okay, so for Bernard's age, we need to use 6 parts because Bernard is 4 times as old as Hector. To make the diagram more clear, we had better use the same shape to represent the same amount, so it's more obvious. And the second, this is not their age now. For this relationship, that is, when Bernard was as old as Hector is now, so that means now Hector should be this age. We need to add an extra part. Actually, you can also see for the orange line, how many triangles do I need to use? Exactly, it is just the 3 triangles. And this is the age for Hector now. Second, because age difference will never change. So the difference between those 2 people's ages should always be 3 triangles. If we want to represent Bernard's current age, we need to add 3 more triangles. Then for the other relationship, it should be when Hector will be as old as Bernard is now. In other words, Hector should become this age. How long have we added? Another 3 triangle. So for Bernard, also we need to add another 3 triangle. These two amount represent 51 ages, 51 years old. Let's see, in the picture, every part we use a triangle to represent. Can you find how many triangles represent 51 years old? Do addition. For the blue lines, it includes 1 plus 4 triangles. For the other parts, there are 4 groups of 3 triangles, so it is 3 times 4. When we are adding them together, we can get nice 17 parts. If 17 parts represents 51 years old, so one part should be 51 divided by 17, which is 3 years old. Let's see. If we want to know how old will Bernard be when Hector turns into 18 years old. So actually, we just need to know a really important part. Difference. In the picture, can you see what is the difference? How many parts does the difference represent? Great, 3 parts. So the difference should be 3 times 3, which is 9. When Hector will be 18, Bernard should be 27. That's how we solve this question. The answer is 27. As you can see, as long as we know the sum difference for multiple relationship, we can draw line segments to represent it. And in the picture, you just need to find one number, one amount, you are able to solve every single part. That's how we do this kind of problem. So, hope you really got it. If you find the last question a bit hard, please contact me and ask me for some easier question. Then, after you solve the basic ones, when you come to the harder ones, it will be much easier for you. Hope you can understand this kind of problem completely. It's really useful and really understand how to use the diagram method. See you next time. Bye.